Welcome to the notes for 9.1.3. Fair warning, it's a little extensive today, so you might want to break this up into pieces. We're basically covering two different things. The first thing that we're going to be covering is absolute value equations, specifically, and then we're going to move on to absolute value inequalities, but they do go hand in hand. So what you might want to do is kind of after we finish with the equations, just take a break, work on just the equations, or walk away from the video and then come back and pick up for the absolute value inequalities. All right, so we do have the notes here that match what you guys have online, so make sure that you have them in front of you so we can go ahead and fill them out as we go. Important to note, absolute value by definition is the distance from zero. Now, remember that if you have like a number line, so if we think about a number line itself, you can have multiple things have the same distance away from zero. And that's important to note here because we are going to have situations like that. So if I draw a little number line over here for myself, and I have 0 on the number line, I want to think about, for example, numbers that have a distance of 2 away from 0. Well, we know the obvious is positive 2. But, so we've got this distance here. So from 0 to 2, that distance is 2. But we also have another number that is 2 units away from 0. It just so happens to be to the left of 0, and that's negative 2. But the distance is 2 units away as well. So we're going to keep that in mind. You're typically going to have two different values that have a distance of whatever's given to you. In this case, the distance was 2. Okay, so we go through and we take a look at the next little grouping of directions here. And there are a couple of things to keep in mind. Distance cannot be negative. You can be going backwards. So if you're walking backwards, you're traveling in maybe a negative direction, but you're still accumulating a positive distance. So distance is never, ever negative, ever. That's important to note. So as we go through and we solve these things, and the whole idea of having multiple things that could be a distance away from 0, we're going to keep that in mind as we're solving. So the first thing that we want to do here on any of these problems, step number 1, is isolate the bars. So get the absolute value by themselves. So anything that looks like it is hanging around the outside of the bars, so anything that's after the bars, before the equal sign, and anything before the bars, all of that stuff needs to go. So you may have something being added or subtracted outside of the bars, that would have to be moved. You could have something dividing the bars, that would have to be moved. And in this case, we have something multiplying the bars, and that's the 4. So what we're going to do here is we're going to get rid of that 4. So we're going to divide by 4 on both sides. So those are going to cancel, and then we're just going to copy down what we have. So absolute value of x minus 5 is equal to 3. So basically what this says is that, so absolute value is distance. So really in a nutshell, what I want to know is what number or numbers, so follow my highlighting as I go here, what numbers represented by the inside have a distance of 3 away from 0. So the what numbers, that's my x minus 5, have a distance that is actually 3 units away from 0. Well, I think the first one that we would think about is, well, maybe you're actually at positive 3. That's possible. But maybe that number, so the stuff inside, could be equal to negative 3. Now, one of the things that I've done in the past for people, and this might help you guys as well, it's kind of a little preliminary step. I know that the absolute value of positive 3 is equal to 3. Notice that what I did here was I took the inside of the bars, x minus 5, and the inside of the bars, 3, and I set them equal to each other. So the inside of the bars could be 3. So that's one way to think about this. So if we did that over here, I also know that the absolute value of negative 3 is equal to 3 as well. So what I did, same idea, I took the inside of the bars and I set it equal to the inside of the bars. And that's how I got this equation. So it's the inside of the bars. So that's one way to think about this. Now, once you've done this and we split them out into our two separate equations, now they're basic equations. This is stuff we know how to handle, no problem. So I'm going to go ahead and solve these little itty-bitty equations. And that's going to give me x equals 8. And if I add this one here, let's cancel, and I get x equals 2. These are my answers to this question, so that if I wanted to check, which you can always do with the equations, you always plug it back in. So if we wanted to verify this, so let's split these guys and let's actually check it. So I go back to the original, so I would have 4 absolute value of x minus 5 is equal to 12. Plug in what I found. Notice at this point, I think it's kind of interesting, notice that the inside of the bars ended up being positive 3. Isn't that what I said up here? The inside of the bars is positive 3. And then we can go ahead and finish this. Now, we want to multiply, well, I got to do the absolute value of 3. So the absolute value of 3 is, well, how far is 3 away from 0? Distance. It's 3. And I know that 4 times 3 is 12, and 12 equals 12. So I know that my x equals 8 is one of the answers. And I can go through and do the exact same thing with the 2. So for absolute value x minus 5 is equal to 12. Now, checking this is not necessary. This is my attempt to show you that yes, in fact, we did get 2 answers that were accurate. Notice here, inside the bars is negative 3. Inside the bars is negative 3. And then I want to multiply this out. So I do 4 times, okay, absolute value of negative 3. Well, how far is negative 3 away from 0? It's 3 units. And I know that that's 12. So this guy also works. So x equals 2 and x equals 8 are both of my solutions. And now we just have some practice problems here. So the process is kind of the same. You just need to make sure that the answers actually make sense, or like proceeding makes sense. So first thing I'm going to do always is I'm going to get the bars by themselves. So anything in front that needs to go, or anything outside and behind needs to go. Even if something was underneath, it's got to go. So in this case, it looks like there's that 5. So let's move that 5 to the other side. I still have the bars. And the only time I'm really going to be like, okay, is this going to work or not? If it's an equation, actually, even if it's an inequality when we get there, is if specifically negative numbers pop up. Okay, well, can the absolute value, so I guess I have to ask myself, can the distance of a number be 7 units away? Yeah, absolutely. 7 units is possible. So one number that if I take the absolute value of it and I get 7, no, that's 7. Notice it's got the inside of the bars now. So the inside of the bars are going to be equal to each other. But then I also know that there's another number. I know that another number that gives me a distance of 7 is -7. So I'm going to do the same thing. I'm going to set the bars. So inside of the bars is equal to inside of the bars. Now you have two little itty bitty equations. So go ahead and pause right now and see if you can go ahead and get those solved. Okay, so I went through and I solved my little itty bitty equations. You are more than welcome to check them if you would like at this point. However, it is not necessary. So I am content with my answers. I have x equals 3 and I have x equals -4 as my solutions. Okay, moving on. Same idea here. We have to move anything that is around the bars. So don't touch anything inside. It's all the stuff on the outside. So anything outside's got to go. Well, you actually have two things that you need to deal with. We need to get rid of the 3. So normally get rid of addition and subtraction first. So let's go ahead and get rid of that guy. Those are going to cancel. But I still have that negative sign there. Well, you guys know that if there is a minus or a negative sign stuck to a number, it's technically a -1 right there. So what I'm going to do is I'm going to get rid of that -1 by dividing by -1. So now those guys cancel. And then 6 divided by -1 is -6. Okay, heightened awareness kicks in. Because I have these absolute value bars, and absolute value means distance from 0, I guess I need to ask myself the question. Can the distance of a number be -6 units away from 0? No, not at all. Distance is always going to either be 0 or positive. It can't be negative. So I don't proceed with this problem. All I'm going to say here is that there is no solution, because there is no number whose distance is a negative unit away from 0. Doesn't make any sense. Okay, number 4. Now, if you want to give this one a shot, that would be great. I am going to go ahead and work through this one as well. So it's up to you guys. If you want to pause now, see if you can work through it ahead like you would in class, and then kind of look up and see and check if you match me or not. All right, let's go ahead and proceed then for the people who want to stay. Anything around the bars has got to go. So I have a ×2 and a -1. Typically get rid of addition and subtraction first. So let's move that guy. And the only time I'm really going to look, if I'm solving equations, the only time I'm going to look to see that heightened awareness kind of kicks in with the positive and negative numbers being on the other side is when I finally get the absolute value by itself. So those are going to cancel. And then this gives me 0. Okay, so now I take a look at this and I ask myself, all right, can the distance of a number be 0 units away? Well, sure. If you're no distance away, then you're 0 units away from 0. So this can happen. It's a little strange, but it can happen. So I think about, well, what number, if I take the absolute value, gives me 0? Well, the only number that is 0 units away from 0 is 0. This is the scenario where you're only going to get one answer, because 0 is neither positive nor negative, so we don't think about two numbers being no units away from 0. So in this case, I think I only have one little tiny equation. So the inside of the bars equal to the inside of the bars. And then I would go ahead and solve that. Now, I know it's a little strange, but if you think about it on the number line, that's the only number that isn't any distance away is 0. Okay, so at this point, make sure, yep, at this point we have finished with the absolute value equations. We're going to move on to absolute value inequalities at this point. So if you want to kind of take a break right now, would be a great time. Maybe come back to this video, or if you want to just charge through and keep going, we're going to do this. So then the next part of the notes is the directions on how we're going to solve this. And I'll be honest with you, I haven't read at you in the past, and I'm really trying to avoid it now. I definitely want to stick with that. So the idea is kind of the same here. We're going to treat it just like we would if it was an equation. And then we're going to go back to the whole inequality business. There are going to be some interesting situations when negative numbers pop up. So if we ever get like a 0 on the other side or a negative on the other side of the inequality, heightened awareness is going to kick in. And we're going to be like, well, is this even possible? So remember, distance cannot be negative. That's important to keep in mind. Okay, so let's take a look at our very first one. So the absolute value, the inequality, absolute value is by itself. So I'm going to think about this. Can the distance be, and I'm going to include the inequality here, can the distance of a number be bigger than 16 units away? Yeah, sure. It could be 17 units away, 18 units away, 28 units away, 153 units away. Maybe a whole bunch of them. So yes, this is possible. So since the inequality is possible once the bars are by themselves, that means that the equation would be possible. So let's find our boundary points. So I'm going to turn this into an equation. And I'll come back and deal with the inequality part in just a minute. All right, so I'm thinking about that whole inside business. So what number is 16 units away? Well, 16. That's one of them. I'm going to do the same thing. What number is 16 units away? Well, that's negative 16. Okay, so now I'm going to do let's set the inside of the bars equal. So the inside of the bars, 3x minus 5, is equal to the inside of the bars, 16. The inside of the bars, 3x minus 5, is equal to the inside of the bars, negative 16. All right, so now we're at the absolute value equations that we just did a minute ago. So I'm going to go ahead and pause. I recommend you do too. And let's just solve these two little equations and figure out what our boundary points are. Okay, so I found my boundary points of 7 and negative 11 thirds. The negative 11 thirds you might want to turn into a mixed number, or maybe even a decimal, just to get an idea of where this goes on the number line. So if I divided this, I think this is negative 3 and 2 thirds. I'm only doing that because of the number line business. All right, so now I have my boundary points, but I'm dealing with an inequality. So now my brain kicks in with what I did 2 class periods ago. So then I'm going to take out my number line. I like to have 0 on my number line. You guys know that. And then I'm going to go ahead and put the other numbers on. So I have a positive 7. So that's over here. And then I have a negative 3 and 2 thirds, and that's right there. Or negative 11 thirds. It's up to you. Okay, at this point, I am going to go back to the original question. And I'm going to take a look at the inequality symbol. So I'm looking right where I just circled in green. Now, I don't know what's happening with the inequality. I've no idea. I'm going to test a point. I'm not going to assume that my arrows are pointing this way. But I do look at the fact that there was an equal to part. So I'm going to go back over to my number line, still using my green pen here. And at my boundaries, because there was an equal to, I'm going to go ahead and fill those dots in at both of my boundary points. Now, at this point, I want to figure out where is this graph going to go? You basically have 2 options at this point. For us this year, won't change this year. except for the weirdo guys we're going to get to at the very end of this. Your graph can do one of two things. Your graph is either going to be connected, so it might look like that, or your graph is going to look like they're running away from each other. That's it for this year. Now, future years, couple years from now, you'll get into stuff a bit more complicated. But for us, they're either going to be connected or they're going to be running away from each other. So with that said, if I take a look at this on my graph, I really have like 3 areas. So one area is kind of over here on the left side. Well, that area would be connected with that one, because if it's going to go to the left on the left-hand side, then the guy on the right-hand side is going to go to the right. So that's one thing. So maybe the graph pieces are there, but I don't know. So the other option is maybe the graph piece is right in the middle here between the two of them. So I'm going to do what I did previously, and I'm going to check some points, but I'm only going to check one. And I like to check one in the middle between the two. So what I'm going to do is I'm going to check a number that is in between -3 2/3 and +7. Now, I'll be honest with you, I'm kind of excited the zero's in there because I love plugging in 0. You know that. So what I'm going to do is I'm going to check x equals 0. And I'm going to see if it works. So I'm going to go back way up to the original inequality. So I'll bring that guy down. So 3x minus 5 greater than or equal to 16. I'll make sure I got that written down right. Yep. Okay, now everywhere I see an x, I'm going to plug in a 0. And then I'm going to do the math. So that's going to give me 0 minus 5. 0 minus 5 is -5. The absolute value of -5. So how far is -5 away from 0? It's 5 units away. Okay, so now I have this inequality. 5 is greater than or equal to 16. I ask myself, does that make sense? Is 5 greater than or equal to 16? Nope, absolutely not. Which means where I checked is no. So my graph isn't going to be in between the two of them. My graph is actually going to be outside. So I'm going to point to the right here. I'm going to point to the left here because the middle was no. It's either middle between or beyond on the outside. So let's get rid of this no now. And we need to write our answer. So if I take a look at the graph, so now I'm back at this whole inequality business. If I take a look at the left-hand side of the graph, I have x was my variable. My boundary was -3 2/3 or -11/3, it's up to you. The dot is filled in, so that gives me an equal to. And then I take a look at where the tip of the arrow is pointing. So it's pointing to the left. Okay, so that's the answer on the left. Let's do the answer on the right. So answer on the right, my variable was x. My boundary is 7. The dot has been filled in, so filled in. And the tip of the arrow is pointing to the right. Now, one other thing. If we take a look at this, you're going to, if the two graphs are running away from each other, there's one other thing that needs to be added in here, and it's the word or. It's that any of your answers can be on the left-hand piece by the -3 2/3, or your answers could be on the right-hand piece. But the numbers can't be in both places simultaneously. So the only other thing we need to do is have the word or. Now, we're done. So our graph, our inequalities, and our word that connects them. Because we don't want it to see as two separate answers. It is either this or that, but technically they all belong together for this single answer to this question. Okay. Next one, just like the previous one. So if you want to give this one a shot, be my guest. I am going to go ahead and work through it as well. But if you want to do it by yourself, go ahead and pause it and then catch up and see how you did. All right, so I look to see if there's anything around my absolute value, and no, there isn't. Okay, so the next thing I'm going to just ask myself if this makes sense. Can the absolute value, so can the distance be smaller than 8? Sure. I could have a distance of 6, or I could have a distance of 4. I have a distance of 1 if I wanted to. Have a distance of 2/3. So yes, this is possible. Since this is possible, I'm going to go ahead and turn it into an equation. So I'm going to proceed just like I did on the previous problem. Then I'm going to think about okay, well, what are those things that could be inside the bars? So to get a distance of 8, well, the number could be 8. To get a distance of 8, the number could be -8. All right, so let's go ahead and write our two little equations here. So inside the bars is equal to inside the bars, and inside the bars is equal to inside the bars. All right, so let's go ahead and solve these guys. Looks like x is going to be equal to 6 is one of the boundary points. Okay, let's do this one. 3x is equal to 2 divided by 3. Looks like our other boundary point is x equals 2/3. Okay, so I'm going to take out my graph now. Now, if it was an equation, I would stop there, but it's not an equation. I have to actually do the graph. So I take out my number line. I like to put 0 on my number line, and I'm going to go and put my numbers in. So 2/3 is positive, but 2/3 is pretty close to 1, so I don't want it to be super, super, super far away. And then, I don't know, let's put the 8 over there somewhere. Oh, not an 8. My goodness, that's a 6. All right, let's go ahead and fill that 6 in. Okay, I'm going to go back up to the inequality part. I'm going to take a look at that guy. Okay, there's no equal to part on it. So at my boundaries, I just have open dots. All right, so now you can decide where you want to check. I like to check in between, personally. So I'm kind of sad because the 0 is not in between right now. So I'm going to take a look at these guys, and I want to check something in between those two. Well, I don't know, we could do like 4. Let's do x equals 4. So I'm going to check x equals 4. All right, go back up to the original inequality. So, absolute value of 3x minus 10 is less than 8. All right, let's plug in our 4. And again, you can plug in anything you want in between those two. Okay, that's going to give me 2. Okay, how far is 2 away from 0? That's 2 units away. Okay, now I need to ask myself if this is true or not. So is 2 smaller than 8? Yes, absolutely. This is a yes, which means in between my graph actually works. So this region is where my answer is. Okay, so I'm still back at this whole inequality business. Previously, when we did just inequalities and we had a graph that looked like this, we wrote it as a single big like chunk of an answer. So I'm going to do that. Okay, so I've got my boundaries here. I've got 2/3 on the left, 6 on the right, my variable in the middle. Okay, so now remember, whenever we do this, we always want to think about reading right to left. So if I started at the right and I went to my graph, then it looks like I am going to be pointing left. So those arrow tips are what I need this thing to look like. Then, if I take a look at my inequalities, so the dots, Notice that at 2/3 and at 6, it's not filled in. So I'm not going to put an equal to part. So let's get rid of that guy because that doesn't make any sense. Now, if the answer is all kind of clumped up together like it is here, then I'm done. I don't need to use a word to connect them because it's clear that it looks like one thing. Well, and that's my answer for this guy. Okay, I am not going to work through this whole one with you guys. I think this is a great opportunity to pause. Let's see if everybody can do this. Let's see if we can get our answer, test our point. So remember, your answer has your boundary points on a number line. It also has the dots either filled in or hollow. It has the graph that either connects the two dots or have the dots kind of runs away from the dots. And you have to have the written out inequality. Okay, so here's my worked out answer. Notice that I included the word or as part of my solution. That's necessary. So take a minute, double check your work. Pause here if you need to. I'm going to move on to the next slide. Okay, much like the previous one, except the bars aren't by themselves. So what I'd like to do, and this is not something we've necessarily focused on too much, and I think I did it in the previous video. If you are going to multiply or divide by a negative number, both sides, then your inequality sign is going to flip on you. So I'm going to try to get the bars by themselves with the inequality symbol in it. So if I take a look, any stuff around the outside's got to go. So it looks like the 6 is going to have to leave, as is the 5. So I'm going to add the 6. Since I am adding the same number to both sides, the inequality sign remains the same. So just drop it down. Now I got to get rid of the 5. So I'm going to divide both sides by 5. Okay, so I'm going to be very aware of what I'm doing here. I am dividing by a positive 5. Dividing by a positive does not flip the inequality sign, so drop the inequality down. Now, see if you can proceed. This question's just like the ones that we've done previously. So take a second, make sure it makes sense. If it makes sense, go ahead and proceed. So here is my work for this question. Notice that when I went back and I checked my value, so I'm over here. I'm over here at my check, so what I just highlighted in green. That I went all the way back up to the original question. So the 5 times 2x plus 3 minus 6 is less than 29. Just in case I made a mistake when I was manipulating it. Let's go ahead and take a minute, check your work, make sure that we match. And then moving on to question number 5. Question number 5 does have a little bit of division in it. So if you want to give this one a shot, try to get those bars by themselves. Now would be the time to pause. I'm going to go ahead and talk through this with everybody else. Okay, so anything that is around, so outside of the bars, those guys got to go. And I'm going to leave the inequality symbol. So I'm going to get rid of the addition and subtraction first. So let's move that 4. Bring down that -2. Now I realize the other side is a negative number. It's not that it's a negative number, it's what you did to get that. So I subtracted the same number. Okay, subtracting doesn't do anything to the inequality symbol. Okay, so now let's get rid of that -2. Those are going to cancel. Keep the bars. If I divide, that gives me a 6. Doesn't matter if it's positive or negative, think about what you did. I divided by a -2. All right, the inequality sign is going to flip around. So this guy is going to flip. Instead of pointing right, it's going to point left. Okay, so now we have to ask ourselves, okay, is this possible? Could the absolute value of a number be smaller than 6? Sure, not a problem. So Go ahead and proceed with the rest of this question just like on the previous page. I'm going to go ahead and pause, fill it all in, and then give you guys a chance to check. So here's the worked out problem now. I went through and split it into the absolute value could be positive 6, or the value that has a distance of 6 could be positive 6, negative 6. Found my boundary points, turned them into mixed numbers, just had a better idea of where they were on the number line, and then checked something in between them. Thankful that 0 was in there, and this was my answer. So if you want to pause, go ahead and double check your work against this. I'm going to go ahead and move on to the next screen. Now, you guys do have these written in your notes, but when I put them onto my iPad, they didn't get transferred over, so I just went ahead and wrote them in for you. So at this point, I got rid of all of the extra stuff around it because I did want to kind of talk about the oddballs and the, oh man, what happens if I have like a 0 or a negative number on the other side? And you really do gotta pay attention and be very careful about this. So I look to see if there's anything around the absolute value bars that need to go, and they don't. I have the absolute value bars all by themselves. So I would definitely isolate the bars just like I did in all of the previous problems. Then I would stop and ask myself, okay, is this possible? Can I have a distance, so a distance, that is bigger than negative 5? Okay, so let's think about that. So can a distance from 0 be bigger than negative 5? Okay, well, let's see. Distance can be 0 or positive. All right, so distance, let's see, can be 0 or bigger. So all positive numbers are bigger than 0. Oh, okay. All right, so can a distance from 0 be bigger than negative 5? Okay, so let's think about things that are bigger than negative 5. So negative 2 is bigger than negative 5, but negative 2 can't be a distance, so that doesn't make any sense. 0 is bigger than negative 5, and I can have a distance of 0, okay. 1 is bigger than negative 5, and I can have a distance bigger than negative 5. Well, let's think about a number line here. So to represent all distances, so let's say I've got negative 5 over here, and let's say 0 is here. So notice that 0 is to the right of negative 5. It's bigger, and it's a feasible distance. All of the numbers to the right are positive numbers. All of the numbers over here are greater than or bigger than negative 5. And all of those are the possible distances just in general. So can a distance from negative 5 from 0 be bigger than negative 5? Yeah, yes, absolutely. Yes, the question is how many of them are there? Well, all of the positive numbers are bigger than negative 5, and 0 is bigger than negative 5. So I guess the question is how many numbers are in there? There's an infinite amount of numbers in there. There's a huge amount of numbers in there, because remember, this box is just going to keep going on to the right. So I don't have a graph for this. I just have an answer of, I go back up to this guy, so how many numbers in existence have a distance greater than a negative number? This is infinite. We have infinite solutions here. So if I wanted a graph, kind of think back to what we did previously when we did infinite solutions, although it looks kind of silly. We would have our number line with 0 on it, and then our graph would just be everything, because everything has a distance greater than a negative number. So infinite solutions for that guy. Okay, now question number 7. doesn't have a negative number on the other side, but it has a 0. We got to think about this. So I'm going to go through and translate this also. So can a distance from 0 be less than 0? Let's see. Can a distance be less than 0? So what kind of numbers are less than 0? Numbers that are less than 0, those are negative numbers. So less than 0, these are negative numbers. So I guess the question is can a distance from 0 be negative? No, not at all. Distance can't be negative. It's not allowed to be. So in this situation, we would say that there is no solution. So if for some reason you would graph this on a number line, it would definitely look strange. There'd be no graph. Like there's nothing. You just have a number line with nothing above it. So there's no points that make this true. And, yep, that finishes these notes.